Thank you for coming. Thank you for inviting me. Despite what Hussey just told you I'm going to talk about, as usual, I'm going to talk about what interests me. Sorry. And yes, we will talk about the climate change, and yes, we'll talk about what the U.S. is doing, but more important, I really want to talk about the future. First of all, I think that relates a lot to what BaseN is doing, a lot of what the presentations are today, but it's also where how we think about the future, how we live into the future is really going to control our coming up with the right answers. First, I want to frame the size of the problem. Let's put it just in the, and this is going to be told true for whether we're talking about climate change or anything else, but, okay? Real problems, permanent dust bowls in the Southwest, permanent dust bowls in Europe and Africa. So again, just to put the problem in perspective, in the 1930s, the American Southwest, the desert Southwest, they came in parts of Texas, Oklahoma, and they plowed what had been prairies to make them into farms. And then the weather dried, they had good rain, the weather dried, and the surface of the earth began to blow away. And the dust storms were so great that the wind would blow literally in South Dakota, Oklahoma, Texas, and 2 days later, in New York City, at noon, you would have to turn your headlights on to see. Anyone saw the pictures this year of the dust storms in Sydney, Australia? It looked like you were looking at Mars. Permanent dust storms because of changing climate. This is the MIT, Massachusetts Institute of Technology, this year. 9% chance global surface temperature will increase by more than 7 degrees centigrade by the end of the century, compared with only less than a 1% chance that it would be limited to only 3 degrees centigrade or less. Sea level rise, 0.8 to 2 meters. I saw there was a report this week. Finnish scientists working with German scientists reevaluated sea level rise and figured that the number was very close to 2 meters by the end of the century, 1.9 meters. For every meter, you have 100 million refugees. Think about where do those 100 million people go? They head to where the water is for terms of drinking and where the water is not for terms of living. That means coming into Europe, coming across Europe, the United States coming in from perhaps from places like Mexico. But for every meter rise, you should expect 100 million refugees. This has to do with risk analysis. We can pass that one. Temperature anomalies. I pulled that up from NOAA in July rather. Places where it's warmer than normal. Recent report this week. Although we're a few weeks away from the end of the year, the meteorologists worldwide, I met with Petri Talas at the Finnish Meteorological Institute about this, the same data he's got. This will be the warmest decade on record, the warmest 10 years ever since man started keeping climate records. Precipitation anomalies. Basically, what's going to happen is, and you'll see more of this, places that are dry will get drier, places that are wet will get wetter, but and on the margin, what you're going to see is places where they get wetter, you're going to have more rain in shorter periods. So monsoons will be more fierce, that sort of stuff. Last year, the drought in Texas alone, $4 billion. Big economics in just even the U.S., just as an example. We just said that one, right? Sorry, duplicate slide, my bad. Interesting, especially this is very relevant in Finland. Pine beetle infestation, which we have in my state of Colorado, also in Canada. I met with this fellow. Projected to kill 80% of merchantable and susceptible lodgepole pine in parts of British Columbia within 10 years. What happens when Finland gets warmer and pests that have been killed off or maintained in their population through cold weather, they begin not to die off, you begin to see this. That's a big number. You're familiar with this graph before, decline in sea ice, something near and dear to the hearts of all of the Nordic countries. Declining sea ice in the Arctic. This map, again, was in September. I could have pulled one up more recently. That's where the ice would normally have been at that time of year, and that's where it is now. Impacts from climate change. It's a hard slide to read. I'm sorry I had scanned it in. But basically, you get the picture. The higher the change, the redder the number, the more trouble you've got. And that's just to warm you up. Now let's talk about another problem. Oil and gas. This is from the Center for Strategic and International Studies. We get a lot of analysis done at the U.S. government. This one is an unclassified study. It brings it up in terms of national security, something that impacts all of us. Look at the numbers. The bottom line, what you're looking at here is, this is their study based, despite everybody's talking about Copenhagen, and this is not just the U.S., this is worldwide, global consumption. 472 quadrillion BTUs rising to 678 quadrillion BTUs, and look at it, 36% of the oil, 36% of the energy portfolio is met by oil then, and they project only 32, drop to 32% here. Not much. Coal, natural gas, oil continue to represent, in their estimation, the lion's share of all of the energy usage 20 years out on the world. This is not about getting to point the finger at one person. This is how everybody is using energy. Growth in oil demand. Basically, these are the OECD countries. You can see where it's declining. In the non-OECD countries, it's growing dramatically. Same thing if you look at, it's a different way of in coal and oil, this is over the next 23 years, but well, this is what they project, so that's a 20-year projection. Ultimately, some decline in coal, oil in OECD countries, increases in others, but you can see overall, the picture in terms of fossil fuel use is not good, going up in the non-OECD countries very, very quickly. Worldwide capital expenditures on oil and gas. I used to be in the oil and gas business. I know what this means. Developing oil and gas supplies takes a lot of capital and it takes a lot of lead time. You don't spend $1 today and get $1 return today. This is classic, right? Oil prices take a hit, the economy takes a hit, and you have a drop, which means many projects in oil and gas development have been put on hold, and they don't just start up again. You don't recapture this time. Anybody who's in a business knows that when you lose business, it takes a lot of time to regain the momentum, the inertia, to regain that business. Very true in the oil and gas business. Who is this smiling face? Does anybody know who this is? How'd you like to have that guy as your dad, huh? Unless it looks like your dad, in which case I apologize. This is actually a very great man. He was an American scientist. He was a geologist who worked for Shell. His name, M. King Hubbard. In the 1950s, in the heyday of America after World War II, when there was an endless amount of oil and gas in the US and our economy was basically the king of the universe, he did some calculus and he said, in the 1950s, actually his first run of the numbers was 1949, but he published it in 1956, I think. And he said, oil production, forget about gas, oil production in the US will peak around 1970, irrespective of new technology. It doesn't matter what you invent, oil production will peak around 1970. He was written off as a lunatic. Shell, 56. This is a quote from an interview at the New York Times, and officers at Shell went through the roof when his report went to the New York Times. Shell wanted him to stop this. They said, you're nuts and this is disruptive. But unfortunately for Shell and for everybody else, when scientists looked at his calculus, they said, he's right.